In this video, I'm going to work through some probability examples. So the first question, we have two fair die are tossed. We want to find the probability that the sum of the two die is 3, the probability that the two dice show the same number, and that the product of the two numbers is even. So we can solve this by listing down all the possible outcomes in the sample space and also in the events. I have here the sample space S, and the possible outcomes are 1, 1, 1, 2, all the way to 1, 6, and then 2, 1, 2, 2 to 2, 6, and all the way to 6, 1, 6, 2, and 6, 6. So notice that we have an entry for 1, 6, and an entry for 6, 1, because this corresponds to the two different cases for the two die. And you notice that there are 36 elements in S. To find part A, we then need to figure out how many elements fall into the event that the sum of the two die is 3. And it turns out that A, this event that we get a sum of 3, has only two elements, 1, 2, and 2, 3. And therefore, the probability of A is equals to the number of elements in A, 2 of them, divided by the number of elements in S, 36 of them, which is 2 over 36, which is 1 over 18. In part B, we want to find the probability that the two die show the same number, and we do it in the same way. We list the outcomes in B, and this is 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6, and there are 6 of them, and therefore the probability of B is 6 over 36, which is 1 over 6. To find part C, we want to find the probability of the product of the two numbers is even. We then have to figure out what elements give this event. And if you think about it a little bit, we find that C consists of these elements: 1, 2, 1, 4, 1, 6, because if any of the two numbers is even, the product will be even. So as long as one of the two numbers is even, it falls under C. And so in the first row of the sample space, 1, 2, 1, 4, and 1, 6 will give you an even product. In the second row, starting with 2, every number from 2, 1 to 2, 6 gives an even number, and so on. And so if you count the elements in C, you find that there are 27 elements, and so the probability of C is 27 over 36, which is 3/4. So in each of these parts, all we did was figure out what are the elements in the event, count them, and then divide by the number of elements in S. In the next question, we have a group of 20 people. 7 are women and 13 are men, and 4 out of the 7 women wear glasses and 2 out of the 13 men wear glasses. And so the question asks, what is the probability that a person chosen randomly from the group is a woman or someone who wears glasses? We can solve this question in two ways, so I'm going to do it in two ways. So the first way, we can draw a Venn diagram. And so here I have a Venn diagram with the rectangle broken up into two parts, one part for women and one part for men, and then a purple shape that goes over these two parts corresponding to people who wear glasses. And so for the information given, we find that there are 4 out of the 7 who are women, and so there are 7 inside the women event, but 4 of them are in the glasses. And furthermore, 2 of the men are wearing glasses, and 11 do not wear glasses. And so now, if you want to find the probability that a person is someone who is either a woman or someone who wears glasses, we just need to count the number of these cases, and it turns out that there are 9 of them, 4 plus 3 plus 2, or 7 women plus 2 men who wear glasses, so 9 out of 20. So that's one way to do this question, just drawing the Venn diagram, allocating the numbers to the different categories, and then counting the number in the correct category. Another way to do this is to use the formulas. We can first define W to be a woman and G to be someone who wears glasses. And what we want to find is to find the probability that we have W or G. So that means probability W union G. And we can then apply the formula. It is equals to the probability of W plus the probability of G minus the probability of W and G. So the probability of W just means the probability of selecting a woman. So there are 20 people and 7 women, so the probability is 7 over 20. Probability of glasses is the probability of selecting someone who wears glasses. And so there are 6 people who wear glasses, divided by 20, so 6 over 20. And then probability of W intersect G is the probability of selecting someone who is a woman and who wears glasses. And so there are 4 women who wear glasses out of the 20. And so the probability of W intersect G is 4 over 20. And so the formula says we take 7 over 20 plus 6 over 20 minus 4 over 20. And this gives you 9 over 20, which is the same answer as our first method. So sometimes there are questions that can be solved in different ways, and so this is one such question. In the last question, in the final question, we have a race where John wins with probability 1 over 3, Paul wins with probability 1 over 4, and Mark wins with probability 1 over 5. And so I want to find the probability that John or Mark wins, and then neither John nor Mark wins. And you find that here we are assuming that there cannot be any tie, so only one person can win. So in the first part, probability John or Mark wins is just the probability that John wins or Mark wins, which is probability that John wins plus probability that Mark wins, and that is 1/3 plus 1/4 equals to 7 over 12. For part B, we want to find the probability that neither John nor Mark wins. And if you think about this, it means that you do not want John or Mark to win. And so this, you can use the complementary event formula. So probability that neither John nor Mark wins is 1 minus the probability that John or Mark wins. And so from the first part, we found that the probability that John or Mark wins is 7 over 12. And so here the answer is 1 minus 7 over 12, which is 5 over 12. So I hope these problems, these worked problems help you understand the material better. That's all for now. Thanks for watching.